Good morning, student. Hope you are all well. Today, I will discuss with you instruction level parallelism. It is a very vital topic for your exam. What is ILP? ILP is a measure of how many operations in a computer program can be performed at same time. In parallel means at the same time, how many operations in a computer program can be executed or can be performed at same time. What is parallel instruction? Parallel instructions are a set of instructions that do not depend on each other to be executed. Suppose there are different types of parallelism. Example, bit level parallelism, where 16-bit add on 8-bit processor. And another example is instruction level parallelism. Also loop level parallelism. Suppose a for loop execute where loop variable I initialize 1 and it will be go on less than equals to 1000 and increment by 1. So I can write here for I equals to 1, I less than equals to 1000 and I equals to I plus 1. Consider the following program where A and B are two operands and addition of A and B store the operand E. E hold result the addition of A and B. And also second line you can see addition of C and D hold the result of additions of C and B F, and also multiplication of E into F, which is stored at operand G. So here operations 3 depends on the results of E and F, which are calculated from operations 1 and 2. So here G cannot be calculated until both of E and F are computed. However, operations 1 and 2 do not depend on any other operations. So they can compute it simultaneously. Suppose if we assume that each operations can be completed in 1 unit of time, then these 3 instructions can be completed in a total of 2 units of time, and which giving an ILP factor of 3 by 2, which means 1.5. ILP means compiler and processor designer it use as much ILP as possible, because ordinary programs are written execute instruction in sequence one after another in the order as written by programmers. But ILP always but ILP allows the compiler and the processors to overlap the execution of multiple instructions or even to change the order in which instructions are executed. So the goal of the ILP is to execute multiple instructions at same time, and it also allows the compiler and the processor to overlap the execution of multiple instructions. And ILP include instruction pipelining, superscalar, out of order execution, register renaming, speculative execution, branch prediction. What is instruction pipeline? It is a technique which is used in the design of modern microprocessors, microcontrollers, and CPUs to increase their instruction throughput. Throughput means the number of instructions that can be executed in a unit of time. Next, pipelining. The main idea is to divide the processing of a CPU instruction into a series of dependent steps of micro instructions with storage at the end of each step, and it allows the CPU's control logic to handle instructions at the processing rate of the slowest step, which is much faster than the time needed to process the instruction as a single step. Example, reduced instruction set computer architecture pipeline is broken into 5 stages and with a set of flip-flops between each stage as follows. In first stage is instruction fetch, next instruction decode and register fetch, and next execution fetch or execute fetch, next memory access fetch, and last one register. Here the vertical axis is successive instruction and the horizontal axis is time. So in the green column, the earliest instruction is in write back stage and the latest instruction is undergoing instruction fetch. Superscalar. A superscalar CPU architecture implements ILP inside a single processor which allows faster CPU throughput at the same clock rate. Why we need superscalar? A superscalar processor executes more than one instruction during a clock cycle. It also dispatches multiple instructions to multiple redundant functional units built inside the processor. And each functional unit is not a separate CPU core, but also an execution resource inside the CPU, such as an arithmetic logic unit, floating point unit, a bit shifter, or a multiplier. Here is the example of superscalar. By fetching and dispatching 2 instructions at a time, a maximum of 2 instructions per cycle can be completed. Next, out of order execution. It is a technique used in most high performance microprocessor. The key concept is to allow the processor to avoid a class of delays that occurs when the data needed to perform an operation are unavailable. Most modern CPU's designs include support for out of order execution. Next, the steps of the out of order execution. First is instruction fetch, next instruction dispatch to an instruction queues. Also it called instruction buffer. Next, the instruction waits in the queue until its input operands are available. Next, the instruction is issued to the appropriate functional units and executed by that unit. The results are queued also and reorder buffer. And the other ILP techniques are register renaming, speculative execution, and branch prediction. Register renaming is a technique used to avoid unnecessary serialization of program operations caused by the reuse of registers by those operations. And speculative execution allows the execution of complete instructions or parts of instruction before being sure whether this execution is required. And last one is branch prediction. It is mainly used to avoid delays cause of control dependencies to be resolved, and it also determines whether a conditional branch in the instruction flow of a program is likely to be taken or not. Thank you, students. See you again. Okay, goodbye.